Hi everyone. My name is Shangmou from the University of Washington. I was just back from my anniversary celebration trip last night, so I'm just somewhere in between vacation and work. But I'm also excited to share this cool analytical tool with you. So anyway, let's talk about research, not my trip at Disneyland. So before diving into this regression discontinuity tool, a few words about myself. I'm a postdoctoral research associate at the UW, the Theobald Lab, a lovely place. My current research work focuses on understanding the way in which instructor practices and student appraisal of classroom climates really generate educational inequity in undergrad STEM education, and developing tools that disrupt inequities, possibly and hopefully. Before joining UW, I got my PhD degree in education at the University of Pittsburgh. Okay, so today I would like to share a useful tool called regression discontinuity in understanding classroom intervention in undergrad STEM. So this tool is well developed in econ research and also some educational policy studies, but not super common in discipline-based educational research. And in our practice, we feel that this tool is pretty handy for instructors and researchers to quickly generate evidence and evaluate their classroom interventions, especially when experimental design and some large-scale data collection is not really feasible at their current stage. There's this something they could consider. So in this presentation, I plan to introduce the basic idea of regression discontinuity, and most importantly, why we need to consider regression discontinuity in DBER and when we could consider RD. I will use a real-world dataset from a classroom intervention we have applied in UW Bio course, but I will try my best to avoid some too many technical details and big tables, I promise. And we will publish this entire work as a method paper, so you can find any more details from that paper. And that paper is currently at R&R stage at CBE Life Science Education, so hopefully you will see that real soon-ish. Okay, I have mentioned several times of effects of classroom intervention, but how do we see the effects of classroom intervention? Let's start with a basic diagram of classroom intervention. When we're talking about the effect of an intervention, we actually mean the effect of being placed or being assigned into an intervention group, and we want to see whether being assigned into an intervention group had any effect on student outcomes. So like if a student is being assigned into an intervention group, we would expect some changes in their learning outcomes. And if a student's not assigned to the intervention group, then we won't expect anything that's happening from this intervention to that student. It could be like, from this diagram, it could be as simple as subtracting their pre-score from their post-score, or it could be as simple as a t-test. But here's a problem. There are many it is so big. There are many unobserved factors that can influence this pretty simple diagram. For one part, if the assignment of the intervention is a function of some other factors, such as, like, for example, students with higher engagement with the classroom had a higher chances to be assigned into an intervention, then our estimation of the intervention effect is no longer a pure estimation of the intervention, is blended with something more. At the same time, some other factors, such as like high school GPA, can directly influence their learning outcomes in undergrad study. So in DBER, there are two common ways that we use to address these problems. First, we can run RCT, the random control trials or experimental design to ensure that students are really randomly assigned into this intervention so that students are really comparable between treated group and untreated group at a large scale. We could also collect a full range of student level information from their high school and their prior learning experiences and their some other background information and run a statistical control models. But if none of these are really feasible for your own practice, for example, it's not feasible to run a full experimental design, or like you don't have any time, you don't have control of the assigned to the classroom, or it's not feasible to collect so many information from students. There are also some other ways to try to simulate the random control trial process, but with certain modifications to also create this comparable condition. And in regression discontinuity design, let's see how we can use this technology to create a comparable condition between treated and untreated students without having to run RCT or collect so many information from students. So here's how we get to a comparable condition. And as I said, I use a real classroom intervention example from UW. So this is a data set from a TA reaching out intervention. We believe that TA interaction is a critical way to increase engagement and improve outcome in undergrad STEM. And in particular, students with lower score or preparation tend to have less TA interactions. So we asked our TA to officially reach out to these students whose cumulative grade before the intervention was below 71.5 points. And we're looking at the student exam at the next exam with the expectation of higher exam score. And this 71.5 is critical in UW Bio students to advance to higher level bio courses. So we picked up this threshold and applied a classroom intervention based on this threshold. This is the plot of their next exam score against the cumulative grade before reaching out. That's the criteria of applying this intervention. And purple dots were students who above 71.5 so that they didn't receive an intervention. And golden dots were students who really received the TA reaching out intervention. Now, the regression discontinuity requires you to narrow down the sample around this threshold. As we're trying to do that right now. As we're narrowing down the sample, students who are still within the sample got very similar cumulative grade before reaching out. And it's getting much more similar if we keep doing that. If we just look at the student right below 71.5 and above 71.5, like this, these two students are really similar in terms of their learning conditions and possibly their educational background. And the only differences between these two students are that student below 71.5 got intervention, and the purple dot student who just above 71.5, that student didn't got an intervention. So they're pretty similar and pretty comparable, but one of them got the intervention, but the other student didn't. And of course, we can just compare two students, but it's not really not doing anything because there's going to be no statistical power. So in fact, there's a tension between getting precise estimation, like we're just comparing two students right above and below the threshold, and generalizing the results. So in regression discontinuity, selecting a good sample is critical, and the process called bandwidth selection. In the upcoming paper, we will run through the process with different bandwidth selection techniques, But here in this presentation, for the presentation purpose, we just picked 26 points as our bandwidth. And in general, it's pretty good to report more than one bandwidth, so we're going to do that as well. But we're going to stick to this bandwidth. So that's our sample for the RD analysis. And now we're ready to visualize the discontinuity. You've heard a lot of discontinuity, but we haven't seen that. Let's actually see that. So first, let's consider a regression line without any intervention. So the relationship between their next score and the score prior to intervention. So it's pretty common. We would expect a positive linear relationship between their prior exam and the future exam scores. And possibly there's no discontinuity. But now we have applied intervention at a certain point. And so we would expect two different regression lines, one for student who got intervention and one for a student who didn't got intervention. So let's see that. So the purple line is the regression line for student who didn't got intervention, and the golden line is the regression line for student who really got intervention. And then if we try to extend the purple line backwards, that's the regression line we would expect to see if there's no intervention at all, because it's just a one positive linear relationship. But now we have a jump at the threshold, and that's the effect of the intervention we're going to estimate, and we call it gamma. And we can try to actually read this, the number of gamma from the figure. It's somewhere around like 5 points. But there are many different ways to actually estimate this gamma from statistical tool or regression tool, because that's regression discontinuity, not reading the figure discontinuity, right? So how do we see the discontinuity through regression? We can run a regression model that estimated the effect of the gamma. So that's the regression line. If you are not super familiar or comfortable with regression model, the gamma is the coefficient we're going to estimate, and the number you can read from the estimation is our estimated intervention effect. And if you can recall from the visualization, this one is the x-axis we saw, and that's the cumulative score, and the exam score is the y-axis we saw. And reach out is the binary indicator for reaching out status, one for student who got intervention, and 0 is for student who didn't got intervention. And of course, gamma is the effect of intervention. And if we put 1 or 0 back to this regression model, we can actually see this equation from our visualization. So let's go back to our visualization and put this regression equation back to this visualization so we can actually see where we can generate this gamma. So we're back to this visualization again. And if you can recall, we can put either 0 and 1 to replace this reach out status. And if we have reach out status as 0, then we have this regression line. And if we can put 1 as a reaching out status, we can have this one. And the only differences between these two is that we have beta 0 plus gamma for the golden regression line, but only beta 0 as an intercept for purple regression line. And if we can find these coefficients from the visualization, we can actually know where we can get this estimation. Okay, so at 0 point, if we try to find the intercept of this purple line, that would be the beta 0, and that's the beta 0 from the visualization, because that's the intercept of the purple line at the 0 point. And now we're adding a gamma to this intercept, so that will be beta 0 plus gamma. And if we run this regression model, we can actually generate the estimation of gamma. So that would be beta 0 plus gamma is the intercept of this golden line. That's beta 0 plus gamma. So if you put beta 0 plus gamma and you remove gamma from this intercept, you can actually get the estimation of the gamma. So let's go back to this regression line, and we can actually see some numbers. Okay, that's the only table, I promise. So we have a different bandwidth, like different sample size, and when we narrow it down the sample, we can have a better estimation of the effect of the intervention from full sample. That's not something we want to do because we really want to compare students who are pretty close to the threshold, so that they have really similar background and learning conditions. So we can really compare these two students, or these two groups of students. And when we narrow down the sample to somewhere around 30 or 20, and our optimal bandwidth 26 points, we can get a pretty good estimation of the TA reaching out is somewhere between 4 and 5. So that's the number you can read from the regression analysis. And also we can run through so many bandwidth from even like 2 points, that's the really minimum bandwidth, to like 60 points. That's basically everyone we have in our data set. And we can have a pretty solid estimation somewhere from 20 to 40 points. And the estimation is somewhere between 4 and 5 points. So that's our baseline estimation of the effect of the TA reaching out intervention. And of course, we can do more than that. We can add an interaction term for students with different backgrounds, like if students who are from first generation group, or student from minoritized group, we can also know if two groups got a similar intervention effect or different. But limited by time, I will skip that part, and you can read that from our paper. And finally, we can try to strengthen our estimation, because there are many more other alternative explanations than the effect of intervention. So here I just present two options that you can try to strengthen your internal validity of the estimation. One is checking other discontinuity embedded within the dataset, not from our intervention. So we picked some other points and say that there might be some other discontinuity at the hypothetical reached out point, but we didn't actually reach out at 85 points. And as you can see, there's no obvious jump at this point, meaning that the jump we saw earlier are maybe actually from the intervention, not embedded within the data set. So that's one possible way. And the other possible way is that we can check alternative outcomes. For example, we check the next exam, but we can also check their final exam. And here's how. So this is the figure I showed earlier. That's the next exam. And we can show, we can run this exactly the same process for the final score. And you can possibly see that we also get some positive effect for a final exam, but it's just the effect size of intervention on final exam is getting lower and lower, because it's like 2 months away from the intervention. So it faded out, but you can still see something, meaning that there possibly some positive effect throughout the carryouts through the quarter, but not super obvious. And there are many more alternative options for you to strengthen your internal validity of the estimation. Okay, I just want to do a quick summary. So regression discontinuity requires a clear defined threshold that determines the intervention. Here we have 71.5 points at the clear threshold, and anyone below that got an intervention, anyone above that didn't got an intervention, and we clearly use that to create our comparable sample. And RD used the data structure to estimate effect under a comparable condition. That's the bandwidth selection process. And also RD addressed data setting limitations, like when we don't have chance to run RCT or we don't have chance to collect the information from students. But the process may decrease the statistical power as well, so there's a tension for that. Okay, thank you so much for that. Here's our lovely group. I don't think we have time for questions, but thank you so much.